Hi, my name is Josh Udy. I'm the Elementary Mathematics Curriculum Manager for the Houston Independent School District. In this video, I will be walking through the steps of how to use a 180-degree protractor to measure angles. If you haven't yet watched the prior video where I walked through how to build a waxed paper protractor with your students, please go and watch that video first, as it lays the foundation for the concepts I'll be addressing in this video. In addition to walking you through how students need to learn how to use a protractor, I'll also be going through some common misconceptions that you will want to watch out for as students begin measuring angles using protractors. And I'll also show you some common ways that this concept of measuring angles with protractors is assessed on a paper pencil test. This is important because usually students won't be given a protractor to measure angles on a test, and they'll have to use a protractor that's simply pictured on the paper to answer the question asked. So I'm going to go ahead and walk through a couple of basic things that you need to go over with your students when they're using a protractor. The first is to make certain that students have the numbers the correct way when they have the protractor on their desk. Sometimes they'll have it flipped upside down and you won't be able to read any of the numbers. So make sure that they have it so that they can read all of the numbers on the protractor. Remind students that a protractor is simply a way to measure angles using very tiny wedges, where in fact each wedge is just 1/360th of a circle. This half-circle protractor shows 180 degrees. Students need to learn that a degree is one wedge when there are 360 total wedges that would equal a full circle. Help students understand that the definition of a degree is a small tiny wedge that is equal to 1/360th of a circle. Remind students that when we're talking about a degree, we're talking about the two rays that cut from the center of the circle out. So we're talking about this very small piece. Orient students to the protractor. Help them understand that they have numbers on the outside of the protractor that go from 0 to 180 clockwise, as well as numbers on the inside of the protractor that go from 0 and 180 counterclockwise. Help students understand that the bottom edge of the protractor is not where the center of the circle was. They need to see that this marking here in the very center is actually the bottom of the protractor, or really it's the bottom of where they're going to measure angles using the protractor. So most protractors have a little line that extends out and connects to where 0 is. So help students understand that just like if they use a ruler, they don't start at the edge of the paper, or they don't start at the edge of the wood. They start where the 0 mark is in order to measure something with length. In the same fashion, they need to start their measurements where the 0 mark is on a protractor. So I'm going to walk through some basic steps and some things that you're going to want to watch for that students do as they learn how to measure angles with a protractor. So get yourself a shape and identify which angle you want to measure. So I'll identify here that I want to measure this angle. And before you have the students even put the protractor to the paper, ask them about that angle. What type of angle is it? Is it an obtuse angle? Is it an acute angle? You want students to benchmark off of their understanding of a 90-degree angle. I know that a 90-degree angle would be right here with that vertex, so this is obviously an obtuse angle. Ask students, well, what does that mean? Well, if it's obtuse, it's going to be more than 90 degrees. Have the students align the protractor so that the center of the protractor is on the vertex that they're measuring. they need to then align all the little lines that go from the center to 0 or the 180 along the side of their shape. Now, because the students know that this is an obtuse angle, have them look at where this second ray crosses the protractor. We're measuring from here all the way around to that marking. The very first misconception that students will have is telling you that this is a 50-degree angle. To me, it looks like it's crossing right at 50 or 130 on the protractor. Ask students to think about this. What type of angle is it? Is it an acute angle? Should the measure be less than 90? No, it's obtuse. The measure is more than 90. This will solve most of your problems when using protractors. If you can just get your students to think about the size of the angle before they actually align their protractor. So here, students want to count. They might be able to count by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. And they can see that the measure of this interior obtuse angle is 130 degrees. Pretty simple. What students will do wrong? Students may line up the very bottom edge of the protractor instead of that center point on the vertex. Then this skews where that other ray crosses. So make certain that students are lining this up here. And then a lot of times they just won't line it up correctly at all. Their protractor just may be skewed, where the zero's down here or the zero's up here, and they are not certain what they're measuring. They may try to measure it going this way, and that's fine. Just make sure that that center point and all the lines going to 0 align to one of the sides of the figure. So if they measure it this way, they'll need to use the outside number scale to see that that is a 130-degree angle. I'm going to go ahead and measure a different angle and walk you through a few additional misconceptions that students may have. So I'm going to measure this angle right here. You might have students mark the angle so that they know exactly what it is they're looking at. And before you set the protractor on the paper, ask them, what kind of angle is this? Is it more than 90? Is it less than 90? Okay, it's less than 90, so we need to have it be an acute angle. What does that mean about what it will measure? It'll measure less than 90 degrees. So we're going to go ahead and line up our protractor here and measure this angle. And I'm going to walk through a couple of things that you'll want to pay attention to. First, I lined up the vertex to the center of that protractor, and I made sure that those lines came over to the 0 mark. Now I'm looking at the number scale and I'm thinking, well, this is an acute angle, so it makes sense for me to look at the numbers on the outside of the protractor. And I'm seeing that it's crossing between 30 and 40. It looks to me like it's about a 35-degree angle. I don't usually see students who will say that this is a 145-degree angle, but they might be reading the inside scale of the protractor instead of the outside scale. So make sure that you have opportunities for the students to measure angles that use the outside scale as well as the inside scale for both obtuse and acute angles. Let me show you a very common mistake that students will make when measuring this angle if they're using the inside scale. So if I were to rotate this shape, and I'm still measuring the same angle, but I line up the center here to 0, and I see that I need to use the inside scale, students may look at this and say that they know that they're using the inside scale. They'll say it's 45 degrees. This measure is 35 degrees. They're looking at the 40, and they're thinking on a number line, numbers go from least to greatest, left to right. And they're looking at that thinking 40, 45, instead of looking at the two tens that it falls in between. So here, when students are using the inside scale, have them pay attention to which two tens the line is drawn through. Here I see it's between 30 and 40. So that means I have a measure of 35 degrees. You can always also have them just count 10, 20, 30, and then 35. If it doesn't line up right on a 5, they can actually use the tick marks on the outside to count by ones. There's one final thing that I want to show you when you're having students measure angles using a protractor. And that is when neither ray of the angle aligns to the 0 mark on the protractor. So let me get, let's come back to this shape, and I'm going to rotate it, and we're going to measure this angle right here, which I'll mark in a different color, green. But this time, I'm going to do something a little tricky. I'm going to line up the vertex of the polygon to the center of the protractor, but I'm not going to line it up to a 0 mark. This is not recommended that students measure angles this way. However, often on assessment items, they will be shown a protractor just like this, where the lines come out and neither of those rays are hitting on the 0 mark. So they need to know how to do this. If I'm just measuring with a protractor, it's going to be easiest if I line it up to 0. But you might pose it as a challenge for your students. Okay, so let's put this here and let's figure out the measure when neither ray is on the 0 mark. I would think that it's okay for one of the rays to be on a 10 mark because it usually is when it's assessed that way. But what you need to help students understand is that they are counting wedges. Each degree is a tiny wedge, and I can count those wedges by 5 wedges at a time, or 5 degrees at a time, or 10 degrees at a time. So I can just look, it's crossing here at the 70 on the outside scale, and let me just count by tens. 10, 20, 30, 40, 45, 46, 47. They can simply just skip count by tens to see that the measure there between those two rays is 10, 20, 30, 45, 46, 47, 47 degrees. You can also have them verify this by turning and measuring using just it lined up to 0, and they should still see that it becomes, we have 45, 46, 47 using there the outside numbers of the protractor. You may also want to see if students can think of any other way to measure this angle. If they're looking at just the numbers, 70 to 110, 15, 16, 17, they could just say, okay, this one's 70 and this one's 117. What's the difference between 70 and 117? Oh, the difference there is 47. The students can just subtract to see that that's 47 degrees. Having them practice this and then turning and verifying it just using the 0 scale will be very good preparation for the types of assessment items that they will see on a paper pencil test. Let me go ahead and go over 2 different questions that are very common that students might see. The first type of question students might see is one where an angle is simply drawn on a protractor. You'll want to make sure that they see the ray here, the angle W is what we were asked to measure in degrees, that it goes from here to here. Same steps. Is it obtuse? Is it acute? Students want to identify that angle W here is obtuse because it's greater than 90 degrees. Now this is easier because this ray lines up on the 0 mark. However, if you notice, they have to use the inside scale. And so if this was a multiple choice item, the very first wrong answer would be 76 degrees. And about half of the students are going to select it if they haven't noticed and practiced all of the things that we've done up to this point. So you'll want to have them look at the inside scale, count it this way, see that it's 100, and then they count by ones. And they see that it's 100, 101, 2, 3, 4. It's a 104 degree angle. That's one type of problem they're going to see. The other type of problem that they're going to see is where an angle like this falls on the protractor, but it doesn't cross either 0 mark. And so here we see that ray DC comes through 50, and over here we see that ray DE comes through about 115. So students here need to realize that they are not just going to tell me that the angle is 115. That would be if the other ray came through 0. They need to see that they're counting the wedges in between. So they can skip count by tens, 10, 20, 30, 40, 50, 60, and then just count by ones or by 5 to see that this is a 65-degree angle. Students can also use the inside numbers to subtract, seeing here that it crosses at 130 and that here it crosses at 65. If they use the inside numbers to subtract, make sure that students read that correctly. Many of them want to say that it's crossing at 75, and they're not looking at the 60 and 70, they're thinking 70, 75 like this is a number line. But because those numbers on the inside read counterclockwise, they need to look at it from right to left. One final misconception that I want to talk about is that students often don't understand that the measure of an angle is determined by the span or spread of the rays and not the actual length of the rays. So as your students are practicing using a protractor, test this misconception out with them. Simply have an angle drawn on paper. So I'll just use the protractor here to draw an angle. And don't make the rays of the angle very long. So we can say this is our angle that we're going to measure. We can put some points here, or we could just call it angle B. I'll just call it angle B. So if I'm going to measure angle B, well, one, if students line up the protractor, they have a problem. That line B doesn't even hit the numbers. So they may struggle to know what to do. You can tell the students, it's okay, that ray means that line just keeps on going. So take the edge of your protractor and continue out the line. Okay, so now they can realign and see, okay, angle B is about 115 degrees. So you'll want to help students know that they can extend the line. Now, if I actually extend the line for this angle going both directions, if I can get this lined up, if I compare this angle where I've extended the lines to the original angle, some students may say that this new, bigger looking angle has a greater measure, but it doesn't. It's exactly the same. The measure isn't about the length of the rays. The measure of an angle doesn't have anything to do with how long those rays are. It has to do with the span here between the two rays. And this span doesn't change. To summarize, students need practice understanding how to align a protractor, knowing that they must align the vertex and one side of a shape to the 0 degree mark of their protractor, how to count using both the outside scale numbers as well as the inside scale numbers. And students need practice when those two rays cross the protractor and neither of the rays cross the 0 degree mark. I hope all of what I've demonstrated for you today is helpful as you continue working with your students in the classroom on developing the understanding of what a degree is and how to measure degrees using a protractor.